Hello guys, sorry about the delay, had some issues with my adapter. But okay, then let's jump right into it because we are a little bit short on time. So quick intro about myself. I've been working with software engineer for the past 7 years. The past 3 years focused on data engineering, so a bunch of different projects on data warehousing, data quality, and event processing. I work at GetYourGuide as a data engineer on the data platform team. And then let's jump into the agenda. So I'm going to just give a quick intro about GetYourGuide, what we do, what is attribution, and how we built our own attribution model at GetYourGuide. So quick intro about us. So we are the world's biggest marketplace for travel activities. So what we do is we connect customers to suppliers so that when you go traveling, you can go to our platform and you're sure to find cool tours and activities that are going to make a big difference on your trip and make sure you have a memorable experience. And we operate on a bunch of different categories. So we do hop-on, hop-off attractions, outdoor activities, walking tours, you name it, you can find on our website. And our goal is to make sure you love where you're going. In order to do that, we need to provide a hassle-free experience. And we do that in 3 steps. So first, we help you discover activities in our catalog with over 40,000 different activities. Then, of course, we build trust by providing verified reviews and 24/7 customer service support on your native language. And it doesn't matter if you're the kind of person who books things in advance or last minute. We always offer the best price, and we provide payment with 16 different currencies. Just some data about us. So yeah, as I said, 40,000 different activities on our website and app. We have over 18 million monthly active users, and we have 450 people from 50 plus different nationalities making this happen. So then, let's jump into attribution. What is attribution? Attribution is the way you describe how your revenue is attributed to specific touch points and to specific channels. So every time you see a brand, you see a website or our app, in our case, you generate a touch point. So let's say if you see us on Google and then you come to our website, you generate the touch point, and the search channel is a paid search. And then let's say another day you come back, this time through the app, and you just literally open the app. That is a different channel, and it's a direct touch point. And then let's say this time you actually converted, so you booked something. The question is, how do you spread this revenue across these different touch points? And that's exactly what attribution is all about. And as you see, there's really no right answer. It's really an approximation because you cannot be 100% sure how much that specific touch point affected the user behavior. So what we aim for, it's a less wrong model. Why it is important? Because if you actually nail it properly, you're able to just shift your marketing spend from low-performing channels to channels that perform better, and you're able to generate more revenue with the same costs. So you pretty much multiply your revenues if you get it right. So this is what a typical conversion path looks like. Let's say a user comes from first from social, so they saw us on Facebook, and then they sign up for the newsletter, they receive the newsletter, then they search for us on Google, and then eventually they come directly to the website, and then they convert. The question then is, how do you distribute revenue to all of these different channels? First option, which is by far the most common, is last click attribution. So in this case, simply the last channel that we saw, we attribute 100% of the revenue for that channel. Of course, this is like very simple. It's very easy to reason about. But as you can see, you're investing money in different campaigns in different channels, and you're simply not attributing any revenue to those. So it's simple, it's easy to implement, but it's very limited. Then you get into multi-touch attribution, and this is when things start to get interesting. Because instead of just attributing revenue to one, or actually to the last channel, you're actually spreading that revenue across all the different touch points that you saw. And this is when you really see a big difference and I'm going to show in a different slide, that the major difference not actually which multi-touch point attribution model you choose, but rather using multi-touch rather than just one touch point. Another model, which is what we use internally, is the position-based model. This one, it's a U-shaped model. So we attribute 40% to the first and 40% to the last, and then 20% is spread evenly across all the other touch points in the middle. So why position-based model? Well, first of all, if you're building all this in-house, it's like a very complex project. You want to first build something that is simple, good enough, and then iterate on top of that. It's also easy to understand and compare with other tools. So for instance, like AdWords and Bing, of course, they provide that kind of stuff as well, and they have very similar algorithms, so you can actually compare what like the users that converted and their share that they claim they have against yours internal attribution model. And you can see on the chart on the corner, so those that are circled are multi-touch attribution models. So one of them is linear, the other one is time decay, the other one is U-shape, the position base. And if you look at the brown one, it's actually random weight. So as I said, the difference is not really so much on the multi-touch model you pick, but rather heavy multi-touch. Those on the edge, they're a single touch attribution model. And this chart here, it's basically how much revenue was attributed to a given channel. Okay, so hopefully at this time you're already thinking, okay, that's great. Attribution is nice, I can spend the same amount of money and generate more revenue, and how did you guys do it? So a simple architecture on what the pipeline for this specific system looks like. We have our API and we also have our website, and on each one of those we collect events. So the website fire events as well as mobile apps to the API. We collect all those events, they go through Kafka, and then we have a consumer that dumps data on an hourly basis to our data lake, and then from there, we're able to connect and enrich this data, first with all the transactional data we have, as well as more SEM data that we download from like from AdWords and Bing. On top of that, we have Databricks. So this is where we actually do crunch the data. We use Airflow for orchestration of all the workflows we have. And on top of Databricks, we have Looker, which is a tool that you can use to generate reports connected to a JDBC connection. So that means even business users that don't know how to write SQL, they can get answers and reports. On Airflow, this is what it looks like. We have 3 different tasks, and each one depends on the previous task. And this is very easy to define on Airflow. I'm going to show you in a second. And here, Airflow already comes with a Databricks operator. So in this case, each one of those tasks, it connects to Databricks through their API, spins up a new cluster, runs the job, saves the data, and then shuts down the cluster. So it's a very cost-effective solution. On Airflow, this is what the orchestration code looks like. This is just a Python snippet. You can specify your cluster. Here, in our case, we have auto-scaling configuration set up. And then we specify the notebooks. So these are literally paths of the notebooks on our Databricks account. Specify the cluster configuration, and then at the very bottom, you define the dependencies. So touchpoint has to run first, and then users, and then revenue. And then I'm going to dig a little bit deeper into each one of those steps. So the touchpoints. As I said, every time a user lands on one of our websites or on our app, we fire this event. And on our side, we call them attribution tracking. And these events, they contain user data as well as SEM and channel data. So this is a snippet. Important things here are, of course, visitor ID and the SEM parameters, for instance. And based on that, we're able to enrich this data even further, getting, for instance, the ad name or ad group name and things like that. So what we do is, on Databricks, we have a notebook, and then we parse these JSON files that are stored on our data lake. we enrich them, and then on top of that, we're able to specify which channel that specific touch point belongs to. So based on a bunch of parameters, you can look at the URL, you can look at the referrer URL, you can look at the query strings, the campaigns, and then you're able to determine which channel the touch point belongs to. So to give you an example what these rules look like, I think right now we have over 25 different channels that we track. And these are some like example rules that we use. So if it's social, so we receive the attribution tracking event, and then we can just check, very simple, if the UTM medium contains paid social brand. Then it's tracked as paid social brand. Another one, slightly more complicated, if it's from social. So sometimes the campaigns are tracked with the social UTM, sometimes they're not. But if there is a referral, and referral comes from a social, which is a list of websites we define, like Twitter, Facebook, LinkedIn, then that touch point also gets assigned to social. And then the output of this first task is we have one table with all of the touch points enriched and with the right channels assigned. So that is the first step. Then users, they can connect to our website through different devices. So let's say you book something on your work computer and then you get home, you open the email with your voucher, and this is like two different devices, two different visitor IDs. And of course, in order to be able to get all the touch points and see all the history of touch points that led to that transaction, we need to map and combine all these different visitor IDs. So one example of what the email looks like, either you can do web to app. So if you receive the email, you can click on this link and the app's going to open, or the normal HTTP link. So let's say you booked something with visitor A, and then you received this email. You're going to have the visitor ID argument as visitor A. And then you open this on a different computer. The moment you log in, even if you have two different visitor IDs, we're able to make this connection, right? Because then we know that both of these visitors belong to the same customer. And then we end up with a table like this, just like a mapping of visitor A to visitor B, and when we found this, this combination. So here we have all the possible combinations. So visitor A to B, B to A, and B to B. And the way we build this is following the example when you booked with visitor ID A, and then you open your computer on a different computer with visitor ID B. You have a data set, and you have this one row. We apply the first function, the add reversed, and all it does is, if you have A to B, it's going to union and generate another B to A. And then on top of that, we have this other function that is called add identity. And this one is going to generate the A to A, B to B mapping. So in the end, with one record A to B, you end up with something like this, so that we cover all the possible cases. Then, once we have the first table with the touch points and the right channels assigned, then we have this user mapping. The next thing is to actually attribute revenue to the right touch points. So what we aim for in the end is a table similar to this. A table where we have on a transaction level all the transactions that happen on our platform alongside their touch points with all the detailed information that we have on that touch point. That means you're able to drill down on specific campaigns, specific ads, and you're able to see exactly how much revenue each one of those is generating. So it's very granular. One important thing is we always look back 30 days. So we have a window from the moment the shopping cart took place, like the transaction timestamp, we look back 30 days. Because in our case, it doesn't really make sense to look at touch points that happened 6 months ago, because it probably has a very, very little influence on your behavior at this point in time. At this table also we have a bunch of different attribution models that we compute just for comparison. But at the end of the day, what we use is the position-based. So if you look at the transaction number 2, the green one, you can see that it took place on the 20th of February, and then you can see all the 4 touch points that are within that range, and then you can see the position-based weight, first and last touch points getting 40% of the revenue, and then the other 2 getting 10%. So this is a snippet of code to see how we build this. First, we start with the transactions. Then from the transactions, we get the touch points that happen within 30 days. In this case here, we just filter in the beginning because it's a partition table, so we're able to filter out and push down the filter. And then we get this visitor-to-visitor table, which is the user mapping. And then we start from transaction. Transactions you get to the visitor-to-visitor. So that means at this point you have all the possible visitor IDs connected to that specific user. And then we get to the touch points. And there you simply join on the visitor ID, and you have this join condition to make sure you only look at those that happen within 30 days. How the attribution models are actually computed, we have different UDFs for each one of those. So this is the UDF for the position-based model, for instance. So we receive the position of that touch point in that specific transaction, and also how many touch points we have for that transaction. And this is done with window functions. I left them out, but they're just window functions. Then, in case you have just 1 touch point, of course, that 1 touch point gets 100%. If you have 2, it's 50-50. If you have more, then it's this U-shape, 40% in the edges and then 20% spread evenly. And this is how we compute it, and this is the final table. So then at the end, we have a table that looks just like this. Of course, this doesn't have all of the columns. Like I didn't add all the touch point attributes here because I don't have enough space. But then you're able to drill down on specific campaign, specific ad groups, and you're able to see exactly how much revenue each one's bringing. Yeah, okay. So looking back, like a couple of challenges we faced. First of all, data quality is very, very hard to achieve. Like in this project, there were 4 different teams involved. So there was the mobile apps team, where they were firing events from the apps. There was the website team, that they were firing events from the website. The SEM team, structuring all the campaigns and make sure they follow the naming conventions, because that's very important. That's how we attribute revenue. That's how we assign the channels. And us, data platform. So in this case, I would maybe do an analysis and find out that some of the URL parameters are not correct. Then I go back to, let's say, the website team. They're like, okay, it's not us. We're parsing it properly. It must be in the search system. Then we go to the performance marketing team, and then they check on AdWords, and then they change it. And then you have to wait until it takes place, and then you can actually look at the data again. So I think we spent good 3-4 weeks almost just making sure data is correct. And that's in this case when like notebooks were very, very handy for us, because we could just make analyze something and then share the notebook, and then everybody knew exactly what was going on. Another important thing is we also backfilled these events for the past 2 years. So if you want to do projections, if you just implement these events last month, you don't have enough data to make good projections. So what we did is we crunched our access logs, and we tried to mimic the behavior of these events. So only firing those in places where they should be fired, and they were able to backfill up to 2 years worth of data, so that we can make projections for next year. That's it from my side. Yeah, we're also hiring if you guys want to join us, and if you have questions, I'm happy to answer.
Hi. Do you handle cross-device attribution, or people coming in on different devices to make a single purchase?
Yeah, we do. So if they come from our app as well, they go through the same pipeline, so then we're able to attribute them. As long as they log in, we're able to connect those users.
Thank you very much for the talk. You mentioned that multi-touch is better than a single touch, and it does not make any difference which multi-touch model to use. But a model is better than other when it is generating more revenue when used or applied. Do you have any evaluation or any way to calculate how a model is performing or how do you compare the models?
Yeah. Yeah. So in this case, as I said, we aim to start simple because we saw that our users, most of them have on average, like 3 or 4 touch points. So that's why multi-touch made sense for us. But now the next step is have incrementality tests. So this is where we can put our attribution model to test. So let's say if our attribution model says that specific campaign is bringing 20,000 euros in revenue each day, one simple thing we can do is we shut that campaign down, and then we see if we lose 20K a day. And based on that, you can improve your attribution model. So this is one way you can test it, for instance.
Thank you very much.
Yeah.
Hi, great talk, thanks. My question was about the time. How did you choose the 30 days? Because I think that's that changes depending on the business, depending on...
Yeah. To be honest, there was no real scientific reasoning behind it. It was mainly based on the kind of customers we have. So if people they go traveling, they usually don't book activities so much in advance. And usually what we see on our platform, the average booking time before it's 14 days. So that's why we picked 30. Although we do have some internal discussions already that we want to bump into 90. But yeah, right now we're still under 30 days. All right, then thank you very much.